So please read the question carefully before answering it. Let me explain the question for you. So there is a circular disc. So this is circular disc which has a smooth, straight grooves. So these are grooves along which a particle can move. So they are drawn from same point A. Then identical particles are released from point A at same instant. These particles then slide down their respective groups. Assuming no friction, we have to find which particle will reach the edge of the disk first. So this is our disk and this is the groove in which particle can move. Let's first analyze how many forces or what kind of forces can be present in this situation or case. So this groove can exert normal force on this particle because there is no frictional force which can act along the inclined surface. So one is normal force which will be perpendicular to the direction in which this particle is moving. If this particle is moving like this, so one force will be normal force exerted by this groove which will be along this direction. So these forces will not affect motion of this particle which is moving along this line because they are perpendicular. So particle is moving in this direction and you are applying force in this direction. So this motion will not be affected by forces which are acting perpendicular to direction of motion of particle. Then what can be other force? Other force can be gravitational force. So this is mg, gravitational force. So these two lines are parallel. If this angle is theta, then this angle will also be equal to theta. So this angle is theta. And I have to take force which is along the groove. So I am resolving this mg or I am breaking this mg into two components. One is mg cos theta, another is mg sin theta. And again, I am not interested in this mg sin theta because particle is moving in this direction. So I have to take force in this direction only. So I know the force which is mg cos theta. I will divide it by mass to get acceleration. So acceleration is g cos theta. So a particle which is moving in this direction, its acceleration is given by g cos theta. Now let particle is moving in this direction. Let this point be f. So if particle is moving in this direction, I am assuming this direction to be x, then perpendicular direction, I am assuming it to be y. Now, let's see this triangle. This is diameter, so its length will be equal to 2r. And diameter subtend 90 degree at circumference. This is property of circle that we are expected to know. So this is the triangle, and this angle is 90 degree. This is 2r, this is theta. So this will be equal to 2r cos theta. So I know this distance is 2r cos theta. Now please see here, since acceleration is constant because theta is not changing and g is constant. Since theta is constant, we can use these formula that S displacement is equal to ut plus half at square. S is equal to ut plus half at square. So initially our particle was here and finally it was here. So what is displacement along x direction? It will be equal to 2r cos theta. So displacement in x direction, I have written it to be 2r cos theta. Since we are releasing this particle here, so initial velocity is 0. And acceleration in this direction, we have already calculated, it is g cos theta. And then I am saying, since acceleration is constant, I can use this formula. Displacement in x direction is equal to uxt plus half axt square. What is displacement in x direction? It is 2r cos theta. Initial velocity in x direction is 0. This will be equal to half. Acceleration in x direction is g cos theta into t square. So this cos theta will get cancelled and t square will comes out to be 4r by g, which implies t will be equal to under root 4r by g. And this expression is independent of angle of inclination. So what does it mean? You will be surprised to know that all the particles will reach circumference at the same time. So correct option is C. And this is very well within the limit of AP syllabus. It only requires basic trigonometric knowledge as well as knowledge of kinematics equation.